Is about some derivatives which we discussed in the previous class. So here is some another derivatives, that is if log of ax is the function, then what we have to do is we have to find the derivative of this, you can say, function. So the derivative of this log ax function is dy over dx, that is equals to 1 over x log of axe, or I can say that 1 over x natural log of a. This is the derivative which we have to prove. So the first step is we have to do is let y is the function, and this function is basically equals to y equals to log of ax. Now in the next step, this is called the step 1. Now I introduce the increment, that y plus del y, that is equals to log of ax plus del x. So this is the equation 2. Now in the next step, I subtract equation 1 and 2. I got that equation, that is del y, that is equals to log of ax plus del x minus log of ax. Now in the next step, I divide both sides with the del x, so del y over del x, that is equals to log of ax plus del x minus log of ax divided by del as a whole divided by del x. Now in the next step, I applied limit on the both sides, so limit del x approaches to 0, del y over del x, which is equals to limit del x approaches to 0, log of ax plus del x minus log of ax divided by del x. Now in the next step, I can say that dy over dx, that is equals to limit. Now here I am letting in the place of del x, I put the value h. So h equals to del x. So putting the value of the h in this equation, in the I can say in the place of del x, here I put the value h. So the equation become log of ax plus h minus log of x divided by h, and here limit h approaches to 0. So here as you can see, dy over dx, that is limit h approaches to 0, log of x plus h minus log of ax divided by h. Now in the next step, I put some property of the logarithm, that if here is minus sign, then I can write this term in the division form. So like this, the limit h approaches to 0, 1 over h, I can say log of a into x plus h divided by x. In the next step, I can say that limit h approaches to 0, 1 over h log of ax. Now here I am simply divide x divided by x, so that result is 1 plus h divided by x as it is, as you can see. Now in the next step, I multiply this equation with x divided by x, so that doesn't change this equation. So multiplying x divided by x here with this term, I got this result, that 1 over x into x over h log of a 1 plus h over x. Now in the next step, simplifying it, h approaches to 0, 1 over x log of ax 1 plus h over x. So here I am again using the property of the log, that if some constant is multiplied, then I can write it in the power of the log. So this x over h is I can write it in the power of this function. So in the next step, I simply make this function, like if this is h over x, I change this or reverse this, you can say this expression in the form of the, if I divide this x with the h, so I got that result 1 over h over x. So like that, as you can see on your screen. So here's the log log of a 1 plus h over x 1 over h over x. So if h approaches to 0, then h over x also I can say approaches to 0. That means the limit h over x approaches to 0, 1 over x log of a 1 plus h over x power 1 over h over x. So here is some result in the calculus. We know that the limit g approaches to 0, 1 plus z power 1 over z, that is always equals to e. So putting the value here, so dy over dx, that is equals to 1 over x as it is because this is the constant, and log of a, and in the place of this function I can say this is basically when limit applied on this function, so this result is equals to e. So 1 over x as it is, log of a as it is, and in the place of this I can write e. So e is here. So that means I can write it as like 1 over x, 1 over log, I divide this term with log of, when I divide this term with the, I can say in the denominator, so that means I am changing these two expressions. So I can write it as 1 over log of EA. So that result is basically, and log of E is basically natural log of A. So the result is 1 over x natural log of A. So this is the derivative of the, you can say, of the log function.